I just wanted to take a moment to say thank you for everybody for joining us. My name is Christina Baxter, and I own Emergency Response Tips, and we work on providing guidance to the operational community for chem-bio rad nuke explosives countermeasures. And I'm joined by Scott Hartley. So Scott, if you want to introduce yourself.
Yes, good morning, everyone. My name is Scott Hartley. I'm the CEO of ProEngine Inc. And so we like to have these webinars to provide educational background on current events and just solutions to educate the community for it. Obviously, I'm not the one putting my life at risk on some of these things. So we obviously want to just make sure that, provide training, and hopefully it's beneficial to everyone.
Okay, so as with all webinars that we do, as from a lot of you, if you're not new to our series, Scott and I try to do one of these webinars at least quarterly, just to provide a service to the community so that they can get some free training on different ideas and patterns. So throughout the year, we always kind of set up and say, what are the things, the hot topics that we should be focusing on? And one of those was sample collection and presentation, because we feel that one of the biggest problems we have in the operational community today is how do we get a good sample that's representative and get that to the instrument of choice? All of these webinars are recorded. And so if you want to go back and watch it again later, or if you miss parts of it, you get on a call, then you can always go back to the ProEngine Academy. It's usually on their YouTube page, and they will send out information about how to get this webinar replay. So we don't send out the slides themselves, but we do send access to the video for everybody. So hopefully, if I can just get Gautier, can you tell me if you can see the screen now?
Yes, I can see your screen, but I cannot see your video.
Okay, yeah, I had the video off. The video wasn't coming up in the hotel room, so probably best for everybody to not have a video of my hotel room anyway. So we're going to start in, and I just want to remind you, all of these are sponsored by ProEngine, but one of the requirements that they have with their education series is that the process must be system agnostic, so that it is for all operators, regardless of whether you have the ProEngine instruments. So what we're going to talk about today is going to be sample collection and presentation. So with that, a couple of things that I want to remind you. When you're taking a sample, we need to make sure that that sample that we're taking represents a portion of the whole. So if we do have a sample that doesn't look equally the same throughout, we may have to take multiple samples. It's always in your best interest to take samples throughout your whole process, whether that's an air sample. My point at one point could be one sample, and I could be 3 steps away and have a completely different profile of the air sample. It's the same thing with solids and liquids. We need to make sure that we're taking enough samples to represent the average. But we also need to make sure that we're using the samples properly. So one of the things that we'll talk about a little bit is most of the sampling that we do in the field is presumptive sampling. There are times when we need to send samples back to a lab to get unequivocal data, whether that be for attribution purposes, or it be for evidence purposes, or it's just to make sure we can confirm what we got in the field. And so we do need to make sure that when we gather that sample, especially when we're having trace samples or small amounts, that we focus in on what are the information pieces we need right now, which is generally about responder or civilian safety. Whereas we also might need to focus on those samples that we may need later, which would be for evidence and those types of things. So we're going to go down both of those roads today, and Scott and I will kind of go back and forth like we usually do on the different topics. So first, we have it divided out by, let's see if I can go here, 3 W's of sampling. So the what, the where, and the which. So when we start thinking about sampling, I like to come up with a sampling plan. What are my objectives? So first, what is it that I'm going to sample? Is it just air samples? Is it solid samples? Is it liquid samples? Or is it all of the above? Where am I going to take that sample? Are there certain specific areas that make it more suitable for sample? For instance, if I'm taking an air sample, Is it something that I expect to be heavier than air, like most chemicals? Or is it something I expect to be lighter than air? If I don't know, am I going to take both? Absolutely. And so understanding where you're taking your sample is really important. If I have a vapor forming sample, where would I capture that vapor? Is the vapor likely to be right above it, gathering, or is it generally to be beside it? So looking at vapor density and those types of things, and where would I get that? But trying to figure out the behavior of the product and understanding what those things mean. And then finally, the which technique am I going to use? There are a whole lot of techniques out there, whether it be real-time sampling and analysis with gas techniques, or if I'm going to take a solid or a liquid and bring the sample to it. And obviously, all of this is going to relate back to what is in your inventory to start with. While I wish we had that Amazon on demand today where we could say, hey, I'm on a call, I need this, and have it magically appear. Unfortunately, we are limited to what is in our inventory. And so what we want to do is figure out, how do we optimize our inventory to give us the best chance of success, and frankly, with the least cost. So unfortunately, that's where it comes down to all of us. So for the sampling purpose, when I'm starting to get my plan, it's really going to be about identifying what I'm trying to inform. So am I only caring with this event about what I'm doing for protection of both us as responders and the civilian population that we're protecting? So that would be trying to figure out, what PPE should I wear? Should I do an evacuation or a shelter in place? Where did that contamination get to? Or, as we talked about in one of our last talks, was how do we determine if our decontamination was effective? So those are some of the things that I start thinking about. But when it starts getting down to those things that could be a law enforcement perspective, we've got to think about the evidence as well. Are we identifying the material? Is it just a presumptive identification? And I say, with no matter what technology you're using, field identification will always be presumptive. So if you need it for evidence, a portion of the sample must be taken first and set aside for laboratory analysis. And the reason behind that is, even though with some of the technologies we use today have different types of standards and things that we can use to ensure that we have, whether it be contamination control, any of that in place, until you're in the laboratory, you can't completely control the environment you're operating in. So for evidence and attribution purposes, we generally take a sample and bring it back to a laboratory. It could be the same exact instrument being used for the identification in the lab, but in a very controlled environment. So for evidence, we've got to think about material identification, minimizing contamination of the evidence, and then the process identification. For attribution, we're really trying to figure out who is the individual or the group or the location where something is occurring, and what are they trying to make? What is the process they're using? This is something we may use with chemical warfare agent production. So somebody's making sulfur mustard, and they're using the process that starts with chlorine and ethylene gas generators. Very different than if they're using the traditional thioglycol method. Okay, and so all of those are very different, but they produce different materials along the way. And so what I'm trying to do is going to be really important. The first thing we have to remember is bulk versus trace when we talk about these technologies. And this is something in the detection community, which means something very different than what it means in, let's say, the drug community or narcotics. So in the detection community, the difference between trace and bulk samples is pretty much what you can see with the naked eye. So a trace detection technology is generally targeting materials with less than a microgram of material available. That may just be gas phase samples, or it may be a solid and liquid with very small amounts, but hard to see with the naked eye. Whereas a bulk sample is something that we can see. So something that's greater than 1 microgram. So reality is, if I'm looking at a microgram on my hand, I'm only going to see a microgram of a crystal on my hand when the light hits it just right, but that would be considered a bulk sample. This gets very different when you're talking about different technologies. So if we're talking about GC mass spec or any of those types of technologies, we're very much in that ultra trace level for solids and liquids. For any of our gas phase technology, we're really talking trace samples. If we're talking Raman or infrared, we're talking bulk samples. We need quite a bit of material to be able to see it. If we're talking from the drug community and you're talking to somebody, they're talking about a trace sample, usually what they mean is that that bulk sample is a mixture and the component they're looking for is a small amount of the bulk sample. And so that's another use of trace, and that's where it gets very confusing in the operational community. For this context today, trace is going to be less than a microgram, so we don't see it with the naked eye. In bulk will be, we do see it with the naked eye. So the first question I'm going to have is how much sample do I need? So if I am sending something back to the lab, it's not always more is better here. There are some times where if I were to think something was a chemical warfare agent and I sent them a whole container of it, they're not going to be happy with me. Reality is I'm going to take a small amount of it, but that's where it becomes really important. I need to make sure the amount I bring to them or package up to ship to them is representative of that larger sample that's there. So how much do I really need? If we're talking about a solid sample, generally less than 10 grams. Okay, if it's a liquid sample, generally less than 5 mils. If we think it's a chemical warfare agent, go down to that 1 mil or less. You don't need to have a whole lot there. 1 milliliter sample in a laboratory is a lot of material out there. When we get to biological samples, it changes it a little bit, because if it's a solid, we're going to try to gather both wet and dry samples. So we'll get the dry sample first if we can, and then get a wet sample of a surface. It might pull up more. It's really going to be about what is your goal. Now, if that sample is for some reason mixed in with soil, let's say somebody is trying to get away from the police and they throw a bag of something and it mixes in with the soil, you're going to need to get a much larger, because they're going to have to do a analysis aliquots of that soil. So usually around 250 grams. If it's a water sample where something has been spilt into a waterway, you're going to have to get more, 250 mils, so that they can try to focus down what they have. So each of these are just examples of recommended amounts, but things that you should think about. Before you send something to the lab, please make sure you have cleared it for radiation and you have cleared it for energetic materials. In the US, we have a unique situation where our laboratories are divided out for chemical samples, biological samples, explosive samples, and radiological samples. That makes it a little bit different because some of the labs, let's say that do biological sampling, may not be able to clear for chemical. And so sometimes you don't only have to check for radiation and energetics, but you may have to rule out some chemical things of that nature as well, especially if it's going to fly. So start thinking about where is that sample going to go, and have that help dictate to you, how do you get that sample prepared? How much do you need, and what do you need to do before you ship that sample? Because the last thing I want you to do is to bring a sample that could be off-gassing in a vehicle where you are in that same vehicle. The next question that comes to me is, where am I going to get the sample? So if you come into a place that looks like the one on the screen, and sadly, this is very common for some of the different laboratories that we get into, in looking at this situation, where are the best places for me to get a sample? So first, let's look at it and think, we're maybe looking for a trace sample. So if I'm looking at a trace sample, I want to come along and say, what surfaces look like they're surfaces that could be touched a lot? I might have a better chance at high touch surfaces to get residue. So for me, I'm looking at that desk surface straight ahead of us. That looks like a place where they're actually doing some work, and therefore I might have a better chance of getting a trace sample off of that surface. Whereas that pile of yellow boxes over to the right, what I might be getting on top of that is dust. Well, that could be a great sample depending upon what they're doing. It doesn't look like it's going to have fingerprint residue, so I might be missing explosives and other things that are stickier, but I could be getting others. So looking at those surfaces where they're using things, you can see on the floor that there's carpet. If you have ever tried sampling from carpet, it is not for the faint of heart. It is something that you've got to practice a lot with. And trying to get samples out of carpets, usually I use a vacuum type sampler for that because it can create quite a hazard if you have a solid, especially particulate that you're trying to get out of carpet, because you can send it all airborne pretty quickly. And so looking at the place and saying, what are those high touch surfaces? So I'm going to go through a series of different ones that I think you should be considering. So first, if it's liquid, a couple of things that are specific to the liquids. We've got to look at the source of the spill. Is it right near a container? That tells us that we want some that's out on the surface and we want some from the container. If it's in a body of water, how did it get there? Do we see a source of where it came from? And then can we get some of the original and some that's in the water or not? Or are we just trying to get what's in the water? Is it a surface spill? So it's something that has a density that is low, or is it something with a density that's high that's mixed in with the water or down at the bottom? Trying to figure that out. Is it something that mixed in well, or is it something that I have that's immiscible and I'm trying to separate those things out? I know for a lot of us, when we first took our original HazMat class, we did a lot of overflow and underflow dams and trying to figure out how would we help ourselves get those liquid samples, or how would we minimize the spread of that liquid. Frankly, I've never had to do a full underflow or overflow dam in the real world, but I know there's people on here that have. The flow characteristics, how fast is that thing moving? Is it a lake where it's just sitting still? Is it a river where it might have in the middle going much faster than it is at the sides? Is it a pipe or a pool? So what are the types of things you're looking at? And then of course, cooling systems. How are we going to get a sample there that's representative? So there's a whole lot of different things to consider as we start looking at how to get that sample. So first off, looking for dead spots. Spots where material may not flow. Okay, so it might be stairwells. It could be, we were talking earlier today about a sample, and in this location, they have kind of a half wall that's before the wall. And then behind it, they actually have a lot of conduits for all the wiring and things behind that half wall. But that's actually where a lot of the samples can get trapped. And so we start thinking about that, there's places there where we might want to gather a sample. Topography. If it is a liquid sample, it's going to flow down that hill. And so trying to figure out where we have things. And of course, the airflow. If there's a building with an airflow, the air intakes around the doors, those areas where we might have deposited sample. Another one to consider is all the surfaces. We often practice sampling on horizontal surfaces. So I have complete confidence that people can get great samples off of horizontal surfaces. But have you tried sampling off of vertical surfaces? And where does that sample stick? How are you going to get that sample? We played around with that a lot for areas where people may wait in lines and may put something onto a bar or something where they're holding their hands, stairwells, those types of things. Have you played around with how are you going to get the sample off of those vertical surfaces? And then just looking at some of the others, glassware, drains, all of those types of things. So let's look at a few of those. So internally, door handles are generally a great place to grab a sample. So if you are sampling from a door handle, or if you are planning to and don't yet have that done, one of the tricks that I like to do is just take sandwich bags, plastic sandwich bags, just like the standard ones you put your sandwich in, and put those over the door handles and things. So if you're trying to open a space and you haven't done your sampling yet and you're trying to enter and do different things, cover that handle up. That way you are preserving some of that sample under there to grab later. But all of those areas where people turn on and off things, whether it's light switches, door handles, water taps, are great places to try to find a sample. Similarly, if we're talking about a process system, so if we're going into a laboratory, where are the valves and things that they turn on and off? Because you're generally going to deposit more there because you're putting your hand there and you're doing a function with your hand. And so the chance of you leaving material there is much better. The fume hoods, going straight to them and trying to get any of the objects and containers that are in there. I like going to a lot of the laboratory equipment and looking at filters, any type of filter. Now, once you get a filter that has been a vacuum filter, where you see a vacuum off the side, I start to get a little bit worried that that material may go airborne if I sample it right there. So sometimes if I can, I'll take the whole filter right to the lab and sample it there. But separatory funnels where you have multiple layers, nice place to take the bottom and get a sample of the bottom layer and come through the top to get a sample of that top layer. Just getting the small amounts you need. On the distillation apparatus, a lot of times you can reach in with Q-tips or those types of sampling things and try to get some sampling materials. But remember, depending upon what they're distilling, you never know if the threat material or the thing of highest interest is over on the distillate side or it's on the start side. And so when you start going through, you might need to take a little bit of care doing that. One of the first places I always go to are the fittings. So if they haven't put a lot of grease in those fittings to get a really tight seal, you often get seepage, especially if it's a gas or vapor forming around those fittings. So for instance, love to take pH paper, M8 paper, all of those things and go right there to the fittings and to try to get it into the fitting a little bit and see if you get any reading. If you're in a laboratory and there are, or even a home, and there are floor sinks and drains, try to grab anything you can from there, or traps in the floor or in the piping. So remember, a lot of your kitchen sinks and things where you may have a lab going on, that U-trap under the sink might be a place where there's deposited material. And so it is a great place to get around there. Another one that I found really interesting is as you get some of those heavier than air vapors and they follow that surface along. So instead of sampling above the container, following the side of the container, you'll see that a lot of the sample will get captured under the lip of the table or desk or whatever surface you're working on. If there's a lip underneath it, you'll see that some of the vapors will start forming in that lip. And it's a great way to get you a decent sample without having to take a bunch of them. Obviously, any of the waste containers, places where they've thrown stuff, are great sources of samples, as well as, frankly, great sources of intelligence information. I'm a firm believer of, if you're in a clandestine laboratory at all, look at the trash and find out what other things they've got going on there. And of course, like we talked about before, air handling units in a room or in a space are fantastic. We've actually used them in cars even. If a car has driven through a space, it's pulling out the air filter in the car. And if there's particulates and things around, you'll have captured some of it and the air filters there as well. So just making sure that you're looking and trying to grab the places which have the most potential to have a good sample. Now, obviously, if it's an open spill, that's quick and easy. Or if there's dirty glassware. I know we were playing around with the MX908 once with some explosive residue on glassware. And while the glassware looked clean, we were still able to measure explosive residue off of it. And so knowing that even if it's clean, it looks clean to the eye, it's still worth trying to take a sample of, because it may be residue that's dried, but you may still be able to get something off of it. And then, of course, process laboratories, just making sure you're looking at resuspension of materials, any of the different phases like we would see in our separatory funnels, labels on containers. We were trying to buy some materials and see if we could get them into the United States not too long ago. And in this case, it was some of the cyanide salts. One of the places that we reached out to did send us the cyanide salt, but when it came in, the label on it said sodium chloride. But it was definitely a cyanide salt. Later, we received another mail item, and that mail item had sodium cyanide labels to replace the labels on the container. So to get through customs and shipping, they mislabeled the material. And that was how it was getting through. So we were trying to figure out what was the pattern. And the reality was it looked like it should have been a sodium chloride container. It had the proper labels, the proper markings, but reality was something completely different inside that container that would have similar qualities of crystalline structure and all of that. So trying to figure out where those things would be and not always believing, especially if it's something, so in the US, we would see a chemical coming from Sigma Aldrich or something like that. If you start seeing the containers with foreign writing and things on them, then it's not something that you would generally expect in an illicit laboratory in your area. So we see a lot of these in the US right now in illicit laboratories. And frankly, I don't know if anybody's on from Taiwan, but I've been known to call colleagues in Taiwan and have them translate containers for us so we know what's in them or supposed to be in them, because we just have not seen them and it's not an easy translation for us. So make sure you don't always believe what the label says and test things. So when you get into these, the places in a laboratory where you're most likely to get the best benefit: glassware, any of the reaction vesicles or flasks, any of the tubing in the bend areas, okay? So as the tubing comes along and it starts to bend, you're gonna start getting deposition of things. At the valves, the closures, and anywhere where there's grease, just know that on the one side, towards the interior of it, you're going to get better samples right there where the grease is. Any of rotary evaporators, filter paper, traps, all great places to get a lot of your material. So as you start standing back and looking at the laboratory that you're entering, start thinking about, if you were a particulate, where would you settle? Okay, so if you're in one of these devices, where exactly would you land? And of course, now let's take it outside. Generally, when we have a sample outside, it's an obvious space. There's been a spill of something, we've been called to it, and it's trying to figure out what exactly that is, whether it's a powder or a liquid. If you haven't ever tried to take samples that are small amounts of sample that are on concrete, concrete is pretty porous. It looks like a nice solid surface until you try sampling off of it. And that can get really interesting, especially when you have powders and things thrown at people. If you're in a vehicle, just remember the steering wheels and the handles are always touched. But one of the areas where I've gotten some great samples before is the seat belt. Okay, so if you have the area on the seat belt where you're bringing it down and clicking it in place, as well as the handles to get in and out of the car, both inside and outside. Another place where you start to see them is where you're opening and closing the trunk of the car, or the boot, whatever you're calling it, for wherever you're calling in from. So great places to start getting samples. But everybody that's using the car is using the steering wheel, the shift, the door handles, and most are using the seat belt of some sort. So try to figure out those areas where they're most likely to touch. And then, of course, the air filters. As I said before, we've pulled them out of vehicles and measured off of those before. I can tell you that in a major city, if you did have a release, you can tell from some of the patrol vehicles how close they were to that release. Now that leads us to, how are we going to get the sample? We start thinking about it and say, what samples are we going to get? Okay, and where are we going to get those? Now we're sitting here and saying, okay, I've got some air sampling, some liquid sample, and I've got some solid samples. And I'm going to have to figure out, what technique am I going to use to grab that sample? So I put these ones over here for the grab samples for gas phase. So any of you people have done this a long time, the Suma canisters and the Tedlar bags we used for years. And a lot of us have them still in our trucks. Very few people actually use them. But we have to start thinking about, where are we going to take the sample? Is it going to be a representative sample of the space? Tedlar bags tend to be a little bit easier because we can do multiple samples pretty easily. The evacuated canisters are easy to take a sample of, but we don't generally have a whole bunch of those lying around to get a good comparison of the whole space. And so trying to figure out what you're going to do for air sampling can be quite difficult. The good news is most of what we're doing is real-time detection in the field. And so with that, we've got to figure out how long must the sensor be in place. And so if you're not paying particular attention to your sensor response time, it's really important that you do. So I'm going to just play this video for you and just watch the video because I put up the timing. So what we're doing here is in this hood, we have ammonia, and I believe it's right around 65 to 70 parts per million, continuously being piped in through the hose up in this corner. It's coming into a mixing chamber and then coming down this tube and getting split so that each of these sensors are hitting at the same point in time. So you can see how they're pushed in to make sure everybody's getting their sample at the same time. What we're looking at here are several different photoionization detectors. We have an IMS detector, an infrared, and the AP4C. And what I'm trying to figure out is which one is going to take different times for detecting ammonia. Now, the manufacturer claims for a lot of these, so the AP4C measures several times a second. These ones, the PIDs, are measuring about every second. Okay, the IMS is several seconds. And then the infrared claims that it's going to be 30 seconds to a minute. It's actually a bit faster than that, than their claims. But what I want you to show is when it hits the AP4C, that is the time it takes really for the gas to come through all the tubing from the cylinder out into the mixing chamber and come through. So the starting point of the sensing is when the gas is opened, and it takes about 10 seconds to come through. So if we watch this, I don't have any sound on it, but what I ended up doing here is just putting up the time profiles. So you're going to see the first one comes up, and it's going to be at 11 seconds, and it's the AP4C measuring ammonia on the nitrogen channel. Okay, so you can start seeing it come up. The PIDs are starting to hit, okay, and then they're going to start to flash. The Explore IR actually hit really early compared to where it said it would. So at 20 seconds, which means that was 9 seconds after it reached the instrument, way faster than they claim. Okay, the PIDs were a little bit slower. It was about 5 seconds before they reached a generous amount reaching them. And some of that could be their tubing and things that they had. Now, remember, all of these, the PIDs and the AP4C, are just claiming detection, not identification. The ChemPro was able to detect it. It was not able to identify it because it's below its identification range. So at this point, it's saying, hey, there's something there. We can't tell you it's ammonia because they need 100 parts per million to tell you it's there. But it took around 35 seconds or so for it to hit. And then, of course, you can start seeing that Explore IR down there on the right-hand side is starting to think, and that's going to come out and tell us unequivocally that it's ammonia. And that takes about a minute's time. And so very cool the way that we can look at all of these in profile and say, we can get our fastest, which is our AP4C, because it measures about 10 times per second. Then we have our PIDs, which are going to measure a couple times for 5 seconds. Then we're going to get our Explore IR to tell us there's something there. Then our ChemPro to say there's something there. And then our Explore IR is going to tell us that we have a unique identification of ammonia with pretty good correlation. And so this was one where we were really excited to have this real-time capability to compare and contrast different types of technologies. Now, I just put this one in here to show you some of the newer sampling systems that we've been using. So in place of the Tedlar bags, I really like these mini cans. And so they go from the size of, like, everybody that knows me, this is a Diet Coke can, okay? So the size of a small can up to much larger sizes. So they're like the Suma canisters, but they're a little bit sleeker and offer a whole lot more in size comparisons. So you can have more of these and be able to get samples and then still ship them back to the laboratory. So that's where I've gone in terms of air sampling now, is vacuum cans, but these mini cans. They also have glass versions of those for certain materials that you may need. The only thing I worry about is knowing myself and my lack of capability in some ways to not break things. That worries me a little bit. Okay, I'm going to turn it over to Scott and let him talk for a little bit.
Yeah, so
Scott?
what we're gonna talk about in a little bit more detail is some principles around collecting of materials or being able to detect materials in different forms for it. So we're starting with vapors. Why vapors are the ones that we need to probably worry about the most is because that can come out and bite us the quickest, and because there's stuff that can come out and see us. So what we're going to show here is first just the A series agents. So these are known as having extremely low vapor pressure. So if you take VX, which in itself has really low vapor pressure, somewhere around, I would say around 0.0007 millimeters of mercury, around 25 degrees Celsius. The A series agents are anywhere from 5 to 10 times lower than that. And so what we're going to do is, even in headspace methods, but you're still able to detect that. So even materials that are known for producing very little materials or very low vapors can still be detected potentially with the right instrument. And so what we're seeing here are, there's a double pipette there. The single one is what holds the A series agent in there. It's released. The device is put over there, and you're getting response. It's an organophosphate, so you're going to get a hit on the phosphorus channel with that. So even though these materials are known for having extremely low vapor pressure, there's still enough atoms, enough material that's released. We're talking in the single to tens of parts per billion in order to see it. Or you can actually sample it and introduce that into the detector. And we're going to talk a little bit more about some of those sampling methods and introduction into the system that can be done as well with that. If we go to the next slide with it.
Scott, I want to answer a couple of the questions real quick, or comments, just because I want to make sure people are still in that same mindset. Before we go on beyond all the sampling, Dion Mazzolini had a couple of great comments here. Screens of electronics. Screens of electronics tend to have a static charge on them, so they will pull the sample to it. So as you saw those electronic screens in some of the samples, those are great places to take a swab sample. The other one that she said, if you don't know Dion, she's was FBI out of Quantico for years, but then out of Seattle. But when you look at this, one of the things to remember is a lot of the places where we see good sample areas are also good sample areas for the DNA evidence collection and the fingerprint evidence collection. So if this is a crime scene, make sure you all coordinate before you start taking samples so that we don't lose the capability to take the others. So really critical information, Dion, and thank you. I completely didn't even pay attention to that today. So the other one, Gary, on the Explore IR, we were not running that in quant mode. And that was because we were doing it as a quick demo. We did not have the quant mode on that instrument at the time. Okay, back over to you, Scott. Sorry.
Okay, no problem at all. So when it comes to the vapors, what we always want to try to first do is sample the vapor in the vapor form. The reason being is that is important operational information that we need to understand and determine. So the first thing you always want to do, especially if you know you have a sensitive device, is to put that device, as similar to what we're seeing, directly over the sample and try and collect information on that. And if you are able to get a hit on it, that's very important information, because the concentration information can then be used to help quantify the nature of the threat. If you need to, obviously those sort of things, because it is in vapor form, it can come out to bite us or to potentially have an impact on us a lot more. We tend to like things in solid form because unless I do something or play Darwin games, it's not going to really come out to get me. But first and foremost, again, is to sample the thing. The next slide will kind of show you, if you don't get a hit over doing the vapor sample, is to now use some headspace methods in order to collect it. Now, always, when you're trying to sample in vapor form, you want to stand, if you're doing outside in particular, where there is some sort of airflow or movement of air in a uniform way, you always want to stand as a person above and then sample below the air. So obviously be cognizant of what that is. You don't want to be standing right in the way where everything's blowing towards you. You want to stay away from that, but that's the better place to sample for it. What we've recently developed is a headspace sampler that can be additionally used for solutions where outside, or if you're trying to build up headspace. And we have a quick video of that that will run with a little bit of a narrative, and then I'll come back to you. So if you want to run that, that's good, Christina. So what you're seeing here, I'll just do a little bit of the narrative on it, so it's not running. It's basically, it comes in a sheet of paper, and you can actually tear that out, take that piece of paper out. And then what you have to do is a couple of things. There's 2 tabs that allow it to come together. So you have to first take those out. So there's 1 tab on either side. Just put it out. That's what allows the device. We have a little bit of a origami type thing going on here. And then also fold the tabs at the top, which will help hold in the materials as well in there. And then you fold each of the creases. There's multiple creases along there. And you form basically a 4-sided square and fold it down, and then place that over the material. And then that'll allow you to build up headspace on there. So you want to obviously put it over much of the material, not try to actually have the sampler come in contact with the material if at all possible. You put that over the material, and then you let it build up some headspace over a couple of seconds, say about 30 seconds to a minute, and then you sample over top of that. So when you're doing headspace, all you're doing is you're able to build up pressure in order for you to better sample those materials and understand what it is. So in those cases, when we're doing head sampling solutions, sometimes the concentration in those cases is less important, but it is important for us to understand the class of materials that you're dealing with, and the nature of, the concentration is important, but not quite as important as is in just pure vapor form. If we go to the next slide, we have a quick video of kind of an example of an organophosphate actually being used. In this case, we're going to put malathion, which is organophosphate, one that's a little bit easier for us to deal with, a little bit safer for us to deal with on this. So in this case, we're doing the same thing, sampling over it, and then using the headspace, and we're able to generate more materials for us to see and understand the class of those materials on there. So this is a quick example of showing how that can be used in an operational scenario to get information on there. But so you're able to significantly increase concentration by simply doing that. Now, especially if you're dealing outside and it's on a windy day, the headspace sampler will be definitely helpful, because it'll just allow you to build up a lot of that material, which will be blown away pretty quickly with the wind. This will allow how to hold it in place so you can then sample and understand what's going on in there. If we go to the next slide, as far as
just for everybody's edification, yes, on that one, when I cut the video, it's not as pretty as it should be, but we literally left that AP4C sitting there for about 30 seconds and never got any hit off of any vapor. And then once we put the headspace sampler down and waited 30 seconds, then we had a huge amount of vapor. So it was really doing a great job of consolidating that vapor that would come off, but getting it into a space we could work with.
Yeah, if you want to go to the next slide. So when we are dealing with liquid sampling, there are a number of different ways that you can actually sample and collect that material for it. Personally, I'm a bigger fan of a pipette or syringe and swab, and less for like the sponge or scooping. The main reason for the bottom two, I mean, it will collect the material, but as you know, sponges don't really hold it very good. And if you're dealing with something that you don't really want to be transferring to a lot of different places, it may not be a good solution for you. If you're just trying to clear a space, then obviously a sponge works a little bit better. But we also need to take into consideration our detection methods that we're utilizing. And that becomes a very important factor for whenever you're trying to do detection with there. So you have to understand your machine as far as the amount of material that's needed for it to be able to detect, as well as the form of the material. So, associated with that, and then how to collect that out of the material. Obviously, if it's inside a container, that can make some challenges for it. So that's where sometimes a pipette or syringe are helpful, because you can actually reach down and get some of that liquid if it's at a lower level in some of those materials. You're trying to obviously do this as fast as possible, but make sure you collect quality samples. So it's always a trade-off associated with some of those things with it. But sampling, having more than one sample and collecting it as much as possible, and not looking to contaminate it with other materials associated with that. Obviously, that's a little bit harder when it's on an open surface that already could be contaminated with other materials. That's why having multiple samples of it becomes important in order to make sure that you can get a good sample out of that, because there can be co-mixing of materials, especially if it's on a common surface that a lot of other things are seeing, or if it's in an area that it's been, for example, with drugs, if it's a common place where it's a pill machine where you've been commingling of materials, sometimes that obviously will have multiple materials in there, which is helpful, but obviously from a detection standpoint, that can make it more complex to see some of those materials with it. If we go to the next slide, what we're doing here is we can also present a sampling tool that we have for helping out with that, and that is we call it either the S4PE or S4PF, and I'll go more into some of the differences for it. But as a general, if you're trying to understand an area, what you want to do is sample around that area and come in contact with. So there's actually a sampler on top of there. You're collecting that material on there, and then you're introducing that into the AP4C in order to detect it. So there is a specific nozzle designed for interfacing with that to collect as much as the vapors that are produced from there. And so what this is both a sampling system and a thermal desorption heater. So what the thermal desorption heater does is it heats up the material. You increase the vapor pressure, allowing more of the materials to be released, and then being able to understand what classes of materials you're dealing with it. Now, as a general rule, as soon as you get a hit on that sensor, in that case, we're getting a hit on an arsenic containing material, you can just pull it away. There's no sense in continuing to expose the device per se. The only case of that would be is if you are potentially suspecting there's a material that has multiple functional groups in there that the detector can detect, then you may need to, especially if we're dealing with something with an organophosphate that may have another material like a sulfur in it, and you want to get hit on both, you would then have to hold it larger in there. But those would be on rather exceptions rather than the rule. As a general rule, as soon as you get a hit, you just take it away, and you can protect the device from just being able to do other samples a lot quicker and seeing from there, as well as not overexposing from the samples to the sensors, and you're getting validation on that. If you go to the next slide, we're going to talk a little bit about the S4PE and the S4PF. So the S4PF is the material on the blacker, the one that's black, versus the green for the S4PE. So the S4PF is relatively new, was introduced about 2 years ago. And so the reason for that was to directly respond to some of the new threat materials that are present out there. So fentanyls, and especially a couple of years ago, the pure fentanyl was more common to have versus cut. And so the melting temperature of that was a much higher. So we needed the ability to go to a lot higher temperatures in order to see these new threat materials. And so that was a primary onus behind its creation. But even though it looks the same as far as the form factor of the device, it's drastically different inside. And we had to totally redesign the scraper, because the problem is when you go above 500 degrees, some of the adhesives and the screen materials that you use for sampling, as well as the actual plastics that make up the scraper, are all compromised at those higher temperatures. So we had to redesign that material. The other thing that we learned is the amount of time or how quickly you heat up samples can actually impact its ability. So for the way I like to describe that is for any of you who've ever made caramel, there's actually a process. If you heat it up too fast, what happens? You burn it and you carbonize it. So we had to come up slower on that temperature. So it actually takes much longer in order to reach that temperature but that's done purposely to allow that material to release more gradually and not suspect it to immediate burning if you just cranked up the temperature very fast on that. So the overall benefit of the system.
Scott, I just lost you. Can you guys hear Scott, or is it just me that can't hear him? Okay, I'll keep going and hopefully Scott will be able to join us. But what we are looking at here, let me see, there's somebody on comments. Okay, Gautier, so no, he's gone. Okay, something has happened to Scott. We don't know. We hope he's okay. But for the sake of this, I'm going to keep going. So reality is, when we were looking at this one, the most important thing to look at was that temperature difference in the temperature ramp allowed us to get a much better efficacy of measuring for a lot of those materials of interest. So even though it was originally designed around narcotics and that type of thing, the A series agents and the V series agents went up greatly in terms of the amount that was able to be vaporized. And so it greatly decreased the amount able to detect. Now I'm going to try to go through some of Scott's here and see. Let me see if I can get that one done. So one of the things that they worked on was sampling efficiency. So in this case, they deposited a droplet of material on a surface. And so that was either VX or the A series agent. And after the evaporation of the solvent, then they went ahead and sampled the surface. So you can see that the A series agents on glass were not great for either of them, but they went up for the VX. And then the A series were much easier to get off of paint than the V series. So it's going to be very dependent upon the materials of interest, but it's going to change between things. But reality is the efficacy went up a whole lot. Same type of thing here as the thermal desorption efficiency. So having the system, so in this case, is only looking at the thermal desorption capability, not the efficiency of the sampler. And so the droplet is put directly on the scraper. And then the system is heated, remembering that your S4PE has a 10-second heat cycle, whereas your S4PF has a 20-second heat cycle, but goes up much higher. And so when you start looking at that efficiency, you ended up with like a 15-fold increase in your capability to get some of these materials in. And you saw that with the decrease in the limits of detection.
Christine, I'm back.
Oh,
I don't
you're
know what
back.
happened.
Okay.
Yeah, you were there, and then I just noticed that I got a message, so I apologize. I don't know what happened, but I'm back now. So you kicked me out for a second. Yeah.
You want to go on to detection efficiency here?
Yes. So an additional thing that we did looking at the new scraper was determining overall collection efficiency of this. So in this case, we're putting a known amount of material on the surface of the scraper and then exposing it to the thermal cycle and seeing our ability to detect it with the actual scraper and its ability to get it off there. So what we're seeing is there is a difference in your ability to take the amount of material off of different surfaces. So we use an aluminum plate and glass. So what this means is we did improve the collection efficiency of the scraper on different surfaces for it. So hopefully you didn't kick out before I said this, but we did make some changes to the actual mesh that's used to collect the material off of the different surfaces, or the mesh that we use to collect the thing, and it improved the overall collection efficiency. And so this is some validation of that. So it's in tandem of both the temperature increase as well as the ability to get that material off the surface, provides increased levels of sensitivity. Go to the next slide, please.
I just want to remind people, if you have both the S4PE and the S4PF, do not use your S4PE scrapers on your S4PF because they will melt.
Right.
Don't ask us how we know this, but they will. Okay, so it's not the place you want to be in. So just remember that they are very specific and they have different colors for that purpose.
Yes. Yeah, that's a good point. And we have seen the other thing too is if you have both, you should carry both, because there's certain situations you can come in where having the additional collection efficiency or the knowledge based on the thermal temperature can be helpful as well. And we have had a couple cases where like it didn't work on the S4PF, but it did on S4PE, but it did on S4PF, and we were able to use that information to help better identify what that material was.
Yeah, I know Gary's on here, and he's the one that we did that with in one of the cases where the S4PE from one agency was not hitting any sample. And then when his agency used their S4PF, they hit it immediately. And it was a very high temperature material because it was a fire suppressant. And they were able to hit it on theirs, whereas the other partners were not. I'm going to go into a couple of other techniques that I really like. This bulk sampling detector, if you haven't seen this one before, Seacoast Sciences made it, and it was a Department of Defense project for us, really on behalf of Dion's team at FBI. And what they were trying to do here was think back to the anthrax events and trying to figure out a way to get a sample that tended to go airborne safely. And so what this is almost like a baby HEPA filter system, but the sampling front end, so that whole nozzle part pops off and is part of your sampler. The vial fits right into your Raman system. So you can actually go from sample straight into the vial. It keeps it completely sealed and allows you to run your samples. Actually has it all completely evidence tagged, everything. So it's a really nice capability. We use it for both bulk solids and liquids. But the whole impetus behind developing this one was that when we followed the standard sampling procedures out there for dry solid samples and using like cards to pull them together, we ended up testing that and realizing that we re-aerosolized a lot of the sample. And while that may not make a big difference for certain materials, it makes a lot of difference for some. And so having a technology like this is fantastic. Sorry, the thing is not working well. Another one that we've done a lot is using needles to be able to get into samples. So in this case, the scenario was that they had this bottle, they were not allowed to access from the cap because there were other materials that were showing up there. And so if they wanted to get a sample of that liquid, they needed to go in from the side. And in this case, they just took a standard trocar needle and were able to pull the sample in, and that allowed them to access that. The reason that we use the trocar needles is it allows us to keep the system sealed after inserting the needle. So because the needles are using a vacuum tube type of system, it allows us to leave the needle in place and effectively seal off that hole. And so works really well for solids and for liquids. Now, if you have a bulk solid or liquid that's in a rugged container, there are systems out there. The one that we use a lot is the Valent Midas sampling system. This one you can actually drill right into munitions and things if you need to. Now, obviously, if that is not your mission set very specifically, then please call your military EOD team that is closest to you and have them deal with the munitions. The last thing we want are people dealing with military ordnance if it is not their forte. So please, you're better off waiting to have somebody come. Now, I show you on the top right, this is one we had made ourselves before Valent was available. In this case, it was a drill bit that allowed us to get the sampling system in place, but also effectively sealed it off. So we were able to get into something, grab that sample out through the needle component, and then seal it back off. Another one that we did was trying to find samples in very awkward places. And so in this case, it was an event where there was a collapsed structure and it kind of had pancaked, but the material we were trying to get was in the trunk of a car underneath the pancaked concrete. And so in order not to contaminate other things, we ended up having these endoscopes made. And so it's attachments to an endoscope. The endoscope itself is a standard endoscope that is used for automotive assessment. So it's a very ruggedized endoscope. So it's not the same one you see for people getting a colonoscopy. But what they did on the end is they got all these different little grippers. There's mirrors, hooks, magnets, okay, any of these different things that we could use that allowed us to see down through and grab the sample. What's really kind of cool, and the one that we worked on was they had a little way that we could encapsulate the sample. So we could pull the sample inside a housing that kept us from cross-contaminating other things in that hard to access space, but also allowed us to preserve the integrity of the sample. And so these are pretty much developed on a one-by-one basis when needed, but we have several that are with FBI and some EPA teams in the United States. So a couple of different things, like Scott had said earlier, very similar. When we start looking at the techniques for solid sampling, we can use some of the ones we just discussed, but there's also different places where we can use swabs, sponges, wipes, all of those types of things. The one thing we have to be careful of is if the sample is potentially biological of nature, I want to make sure that the wipes and the swabs and things that I use are not organic based, because it could interfere with our PCR sampling. So there's very critical ones that we use if we are using for a PCR sample, so polymerase chain reaction. So if that's the case, just make sure you know what swabs you're using and how they're going to interact with your ability to do your final sampling. And of course, if you're talking about a surface, we always practice with these perfect surfaces. But when those surfaces start to get rough, we start to have more problems gathering stuff. In some surfaces, which look to the naked eye as if they're a nice and even surface, may not be. And so there may be little nooks and crannies where the material's sitting. And so I want to talk to you about some of those different things. When you get to a solid, you may start considering about wet and dry sampling. And just remember, it's going to depend upon which way you're going to detect on whether you can do that. So this is just one showing you, this is kind of a needle type of approach of getting a small amount of sample out of a bulk. So this was meant to be like a kilo type of sample, and it was literally using a pipette with a sharp tip to be able to get in there and get a little bit back, and then we're Ken taping over that. What we didn't want to do was bulk open that kilo. And so it was really about getting a small aliquot out. It was a solid. We now have enough that we can do Raman, we can do infrared, whatever we need to do, but we did not open up that sample in a way in which it allowed the material to go airborne. Another one that I liked playing around with, and we did a lot of work on this one, was trying to find what was our best sampler. And so as we went through and looked at different samplers, we looked at everything from the Teflon samplers to all the different cotton muslin samplers, the Nomex, and every one of them had pros and cons. But what we really found out was just getting standard Whatman filter paper worked really well. Okay, so the same filter paper we can buy on Amazon, we can get at Walmart, but what made it work even better was to rough it up a little bit. So take some mild sandpaper, roughen up your paper, and what it ended up doing was increasing that sampling efficiency. So it kind of had all these little fibers sticking out. And so as you had a surface you were wiping that was not necessarily solid in every way, it allowed those little fingers almost of fiber to reach down and grab more sample. So in this case, what we generally are doing is taking a wipe sample inside a place, rolling that wipe sample up, putting it in a vial and taking it out and sampling off of it. So generally, if I have a very trace sample on a surface, this is something I would do to try to get as much of that sample up as possible, and then I still have this available to sample off of. But remember, we're now talking about an organic surface, and so that can create problem with certain things. Another one always keeping around is tape. So you can use regular old Scotch tape as long as it's clear to do things like Raman and infrared, and focusing in your tight particle spacing. But if you only have some residue on a surface, this is great for when you're doing it on carpet and those types of things. is just using some tape. And all you're trying to do is focus those particles closer. That allows you to get enough particles to get a good Raman signal. But the reason I generally use fingerprint lift tape is that it allows us to bring it back to the lab afterwards and have them extract straight off of it. If you use traditional Scotch tape, a lot of times the hexane extractions that they do in the laboratory for GC mass spec analysis will take that adhesive off and ruin the sample. And so if it is something that's going in for evidence, I just find that fingerprint lift tape works really nicely. You can focus in your particles. If you want to run infrared, you can run the sample of clean fingerprint lift tape first as your background, and then try to run your sample of particles. Same thing for Raman. You can just go ahead and try to focus in on those particles. So really nice way to grab some of your sample. But again, think about where that sample needs to go later. So as we go through this, I just wanted to quickly talk about all these things, mainly to get everybody thinking. So first off, make sure you develop a sampling plan. Make sure everybody's on the same page. And that, like Dion said, is bring in your law enforcement partners before you start doing some of this, because if it is a crime scene, we don't want to lose the capability to take other things. So if we go and take a swab sample of something, we may have lost all capability for fingerprints. We may have taken the DNA up with it. That's not going to be put you in a great space with your people doing evidence collection. So gas, vapor, pretty simple. Most of the things we're doing are real time, or we're getting a grab sample. When we get into liquid, trying to figure out where the sample is, how fast it's moving, and how we're going to capture it. And then the solid, just figuring out, can we get representative samples? What are we going to do with it? But it's always going to be important to remember, what are we going to do with that sample, and how is the information going to be used? With that, Scott, do you have any closing moments before we go to any more questions?
No, I think I'm pretty good.
Okay, so I think most of what we're doing here, let's see. Oh, question from Gerald. Does it make sense to insert the scraper S4PE from the bottom of or side instead of the top to decrease the risk of powder dropping in the AP4C intake? Now, I've never had the powder get into the intake. However, I do sometimes do it from the side or from the bottom, just depending upon ease of access. Any comment on that one, Scott?
No, I agree. I mean, if you are concerned about that, then you can move it around a little bit. But yeah, probably in that case, I would do it more from the side than from the bottom, just because depending on the vapor pressure of the materials and stuff like that, it may not work quite as well.
Yeah, and then a couple of different things when we start getting to the new sampler, the origami sampler that Olivier at ProEngine designed. That was based upon discussions where I used to always carry a funnel with me from creating headspace on my sampling missions. But with that said, the funnel that I used started out always with the old plastic funnels, and that was all great. But then those silicone funnels came out, and they fold down to a nice flat piece. And so I would have some silicone funnels always in my evidence sampling kit. The problem we have is that the silicone funnels absorb all the organics. And so you end up getting a lot of your material getting absorbed into the sampler instead. And so when Olivier came forward and said, well, what about doing this? I was looking at him like, dude, you're crazy. There is no way that's going to work. And then he did it. And it works. And so I've been playing around with them. I just got some more to play around with, but really nice, low cost, simple. But reality is it works. And so we're forever grateful for that. On the swab samples, Andrew was asking for recommended solvent. As a general rule, when I do a swab sample with a liquid, I'm usually using a buffer solution. And so it's generally, if I'm taking liquid ones, I'm really taking them for a biological use. And so then I just use the same buffer that I use for everything else. And so hopefully that answers your questions. Just a reminder to all of you, if you have questions, please feel free to reach out to Scott or I. Our emails are on the screen, as well as our phone numbers. Those are our cell phones, so you can always get us. Also, remember that the ProEngine Academy policy is that all of these webinars will be posted for you to go back and look at things if you have the desire, or to share it with your team for more information. So thank you guys. I know we went a little over, as we always do. That's why we set aside an hour and a half, just in case. But this is one of those topics that we are really passionate about. So thank you for your attention. And with that, we will say goodbye.